All right, sine theta equals 0. Sine theta equals 0 or 1 or negative 1. Those can be solved with the graphs. And the idea is this. First off, typically we need to be given an interval of interest. Usually, this is not set in concrete, but usually it's one of two things. Usually the interval is either from 0 to 2 pi, which is the standard 1 revolution, or if it's not that, it's usually all real numbers, all solutions. So we solve usually on either this interval or this interval. All right? Usually. That's not set in concrete, but usually that's what happens. So, for now, what we will do, this is a little more challenging. For now, until further notice, everything we're going to do, we're going to solve from 0 to 2 pi. Do not include 2 pi. So 0 to 2 pi, including 0, not including 2 pi. All right? So even if we don't write this, from here until further notice, we assume we're solving from 0 to 2 pi, include 0, do not include 2 pi. All right? So until further notice, that's what we're working with. So with that proviso, all we need to solve this equation is to know what this graph looks like. A function is equal to 0 means the graph intersects the x-axis. Well, this graph, the graph of this function intersects at 0, intersects at pi. It would have used 2 pi, but we're not including 2 pi. So, we want to find all the values of theta, which when you substitute here, sine of that number is 0. Well, since the curve intersects the axis at 0, so this is theta equals 0, this is theta equal pi. So the two solutions are theta equals 0, theta equal pi. That's it. There is no work to show. In fact, you don't even need to write this down as far as I'm concerned. Ideally, and this really is the ideal, ideally, if you're asked to solve this equation, you see this picture in your mind's eye without needing to write it down. Because you can visualize, if you know it, you can visualize it much faster than you can draw this. But if nothing else, draw this picture. But you draw this either physically or mentally. Ideally, you draw this mentally. You see this equation, you draw this picture mentally. Where does it cross the axis? At 0, at pi. You're done. And sine theta equals 0 or 1 or negative 1. Cosine theta equals 0 or 1 or negative 1. And tangent theta equals 0. All of those 7 equations work the same way. So let's see if we can work a few more of these. See if we can see this without needing to write out the picture, the graph of the function again. Suppose we want cosine theta is equal to 0. Again, 0 to 2 pi. We have cosine theta is equal to 0. Look in your mind's eye, look over here if you need to, look in your mind's eye to see the cosine graph. Where does cosine cross the x-axis? Cosine starts at the peak. The first node where it crosses the axis is at pi over 2. Then it has the trough at pi. Then it comes back and has another node at 3 pi over 2. And then has another peak at 2 pi. So where does it cross the axis? Theta is equal to where this curve crosses the axis. That's at pi over 2 and 3 pi over 2. No muss, no fuss, no work required. I don't require you show any work. This is one of those places where students say, is it okay if we don't show our work? I'm saying, not only is it okay not to show your work, I kind of prefer you don't show your work. And then sometimes students say, well, please, can we show work? No, just ideally, you don't need to show that work. Okay, here we go. Number 3. What if we have sine of theta? And there's nothing magic about theta. We could have any other variable here. Sine of t equals, let's say, -1. Okay, look at the sine curve. Where does the sine curve have a trough? Where does the sine curve bottom out? If you see it in your mind's eye, you see the same thing as what you see in this picture. Sine curve has a trough, it bottoms out when x is equal to, or in the input value, the domain value, is equal to 3 pi over 2. So no muss, no fuss. Immediately from knowing the graph of sine, we know that t is 3 pi over 2, the end. No work, nothing to show. All right? Let's try cosine theta equal 1. Where does cosine have the peak? Well, cosine starts at the peak, goes through the cycle, and ends at the peak, but we're not including the end point because we're only going from 0 to 2 pi, not including 2 pi. So the only peak value we're taking from cosine is at theta equals 0, the end. The only value we're picking off is where does cosine equal peak. And that's at the domain value of 0. All right? So when we're solving these equations, what we're asked to do is find the domain value. So any of those basic equations, equations that require only the graph, you should be able to solve without reference to the picture. One last bit. Tangent theta equals 0. That's sort of that special picture. We know what the graph of tangent looks like. Where does tangent cross the axis? Yeah, at theta equals 0. But we're solving from 0 to 2 pi. There's more to the picture than this. Because the next comes out here. This is 0. This is pi. Where's the next one? This is 2 pi. Since this is the interval of interest, you do include the 0, you do include pi, you do not include 2 pi. So tangent theta equals 0. Tangent's the tricky one. This is where we need to have two periods of the function drawn. So this gives us immediately that theta is equal to 0 and theta is equal to pi.